In the 9th class, you learnt about elements. Elements are substances made up of same type of atoms. All the atoms in an element are of the same type. And elements were classified into three. We had the metals. Example of metals was copper, iron, aluminium, mercury, and many more. Then you learnt also what were metalloids. Metalloids were substances that had properties between metals and non-metals, like silicon, boron, germanium, were all called metalloids. And then we had the third group called the non-metals, which were like chlorine, bromine, hydrogen, nitrogen, and many others. In this chapter, we are going to learn the difference between metals and non-metals, the difference in their physical properties and their chemical properties. Let's list some of the properties of metals. Metals in their pure state, when they are freshly made, have a shining surface. This property is called metallic luster. Here you can see that is copper. This lamp is made of copper. It's nice and shining. And these two rolls may be made of aluminium and the other could be gold, and they're shiny. This property of metals to have a shiny surface is called metallic luster. But as the vessels are kept for some time, they lose their shine. Like here you see the vessel has become dull. This is a dull copper vessel, and that is because metals are very reactive. They react with oxygen or maybe carbon dioxide or sulfur dioxide from the air and form compounds, and thus lose their luster. So usually when we want our metals to be shiny, we rub the surface of the metal and remove this compound that is formed, and the metallic luster of that vessel returns. So the first property we learned about metals is that they have this metallic luster, this shining surface in their pure state. Why do surfaces of metals become dull after some time? Metals are reactive. They combine with oxygen, carbon dioxide or other substances to form compounds. Hence they lose their luster. The next property of metals are generally hard. However, the hardness of metals vary. Means some metals are harder than the other. In fact, the metals like lithium, sodium and potassium, these are soft metals and can be easily cut with a knife. Whereas aluminium, iron are much harder. Aluminium is a little softer than iron. So metals are hard and they vary in their hardness. For another property of metals, we see that metals can be beaten or hammered into thin sheets. This property is called malleability. In this picture you can see gold, and gold is one of the most malleable metals. Here this gold is beaten into this thin sheet, and hence gold is said to be malleable. We are also familiar with aluminium foil, and we can have aluminium foil because aluminium is malleable. It can be turned into thin sheets. Here we have iron sheet, which is maybe covered with some other metal to prevent rusting. So metals have this property to be beaten into thin sheets. This property is called malleability. There's yet another property of metals. The ability of metals to be drawn into thin wires is called ductility. So in this picture you can see the wires made up of metal. In our homes we have copper wires, aluminum wires that we use for electricity. They're all made because of this property of metals to be drawn into wires. Among all the metals, the most ductile metal is gold. From 1 gram of gold, you can draw a wire that is 2 kilometers long. Just from 1 gram of gold. So a 2 kilometer length wire can be drawn from 1 gram of gold. So gold is the most ductile metal. For another property of metals, metals are good conductors of heat. Like we have copper, gold, aluminum, they're all good conductors of heat. However, wood is not a good conductor of heat. Wood is not a metal, but wood is not a good conductor of heat. That is why in our cooking vessels, we always use wooden handles. And these wooden handles do not allow heat to pass through it. Although our vessels may get very hot, these vessels get hot because they are heated, but the handles do not allow the heat to pass through. So when we hold on to the handle in this area, we do not feel the heat because wood does not allow heat to pass through it. Here's another example where the kettle becomes very hot. It allows heat to pass through it, and that's the reason why all kettles, we have this little wooden handle here to make sure that the heat does not pass on to the handle, and we can easily hold on to the kettle. Here next is an activity to show that metals conduct heat. So we need to take a wire, maybe of aluminum, or it could be of copper, any metallic wire, and clamp this wire onto a stand. Like here, we have clamped it, we have held it, fixed it to a stand. Fix a pin to the free end of the wire using wax. So here is a pin here, and this pin is fixed to the stand by using some wax in between. Heat the wire with a spirit lamp. Like in this picture, you can see the wire is heated with a spirit lamp or a burner near the place where it is clamped. Now what will you observe? After some time you will find that the heat moves through this wire to this metal, and then the wax out here melts, and because this wax melts, the pin now drops. It was the wax that kept the pin stuck to the metal wire, but the pin drops because the wax melts. Now why did the wax melt? You did not heat the wax directly. You heated this metallic rod, and this metallic rod conducts heat. It allows heat to pass through it, hence the other end also becomes hot and the wax melted. So thus we see metals are good conductors of heat. They have a high melting point. Now the best conductors of heat are two metals, silver and copper are the best conductors of heat. However, the poor conductors of heat are lead and mercury. They do conduct heat, but not as well as other metals. They are the poorest conductors of heat, lead and mercury. So here was another physical property of metals. They are good conductors of heat. is yet another property of metals. Metals conduct electricity, which means they allow electricity to pass through them. Here's a little setup to show or prove that metals conduct electricity. So we could take a sample of a metal, maybe a copper strip, and place it between these clips A and B. Here, this is a copper strip. And as soon as you place this copper strip between A and B, you have made the connection. And the current now begins to flow through this circuit. And as the current flows through this circuit, you will find that the bulb will begin to glow. This clearly shows that copper conducts electricity. However, if you place a substance like plastic or a substance called PVC, PVC means it's polyvinyl chloride. It stands for PVC. And this polyvinyl chloride, when you place it between A, B, here you do PVC, you find that the bulb does not glow. And why does a bulb not glow? Because PVC does not allow current to pass through it. It does not conduct electricity. Hence, the bulb does not glow. But metals allow current to pass through it. So if you place a metal here in this region, if there is a metal, immediately the bulb will begin to glow. In this picture here, we see that all the wires have been given a coating of PVC, different colored coating of PVC. So why are electrical wires coated with PVC? Wires are coated with PVC. You know the meaning of PVC is polyvinyl chloride. Because it is an insulator, this prevents from getting shocks. The current does not leak out of or does not spread in that area because they are coated with PVC. PVC does not allow the current to pass through it. This prevents shocks. We have seen that bells are made of metals. Even gongs, which are used to produce sound, are made of metals. Cymbals used in music are also made of metal. And in this drum set, here we have these parts made of metal. This is because metals are sonorous. Metals that produce a sound on striking a hard surface are said to be sonorous. And because metals are sonorous, they can be used to make bells, gongs, cymbals, etc. All metals are not sonorous. It's only some metals that are sonorous. Now we learn about non-metals. Examples of non-metals are carbon. Then sulfur is also a non-metal. Then we have iodine, which is nice purple violet color. That is also a non-metal. Now the properties of non-metal, they're brittle, they're not hard, they break quite easily. Then they do not conduct electricity. Metals conduct. Here they do not conduct electricity. They do not conduct heat and electricity. And most non-metals are non-lustrous. They are not shiny. Except for iodine. Iodine is a non-metal, but it has got luster. It's lustrous. Another point we need to remember is non-metals are either solids or gases. The only non-metal that is a liquid is bromine. So we need to remember this. The only non-metal that is a liquid is bromine. And in metals, most metals are all solids except mercury. Mercury is an only metal that is a liquid. Here are some of the differences between metals and non-metals. First, metals exist as solids except for mercury, and non-metals exist as solids or gases except bromine, which is a liquid. Then for another difference, they are sonorous. They make sound. Non-metals are non-sonorous. Metals are conductors of heat and electricity. Non-metals do not conduct heat and electricity, except graphite. Graphite conducts electricity. Then another point here is metals are lustrous and nice and shiny, but non-metals are non-lustrous except iodine. Iodine is lustrous non-metal. There are other points which I have not put down here. For example, comes to malleability. Metals are malleable. Non-metals are non-malleable. Ductility. Metals are ductile. Non-metals are non-ductile. Now to remember some exceptions. All metals exist as solids except for mercury, which exists as a liquid at room temperature. The next point is most metals have high melting point. But to this also we have an exception, and that's gallium and cesium. These are metals with low melting point. They are so low that they can even melt in your palm. So the melting point is less than the body temperature. Then the next point is iodine is a non-metal, but it is lustrous. Non-metals are usually not shining, not lustrous, but iodine is lustrous. And most metals are hard. And to this too we have an exception, like the alkali metals, which are lithium, sodium, they are called the alkali, and potassium. These metals are so soft that they can be cut with a knife. To understand allotropy, let us take the example of carbon. Now, carbon exists in different forms. Like we can see in this picture, you have diamond is a one form of carbon. Graphite that we use in our pencils is also a kind of carbon. And this amorphous carbon, this powdered carbon, is also a form of carbon. Now, all these have very different properties. It's very obvious that the diamond is so different from the graphite that we use in the pencil. Both are made up of carbon atoms. Like you can see in this picture, they're all made up of the same carbon atoms. But the arrangement of carbon atoms is different. And as the arrangement of carbon atoms is different, these substances show different properties. They show same chemical properties because they are made up of same kind of atoms, but they show different physical properties because the atoms are arranged in a different manner. So in diamond, it's the hardest substance. It's the hardest natural substance. And it has a very high melting point. But when we go to graphite, graphite of course is a non-metal, diamond also is a non-metal, but graphite conducts electricity. It's the only non-metal that conducts electricity, and this is because the difference in the arrangement of its atoms. So allotropes are different forms of an element that exhibit same chemical properties. Why same chemical properties? They're made up of same kind of atoms, but different physical properties due to the difference in the arrangement of the atoms. So the different allotropic forms of carbon are diamond, graphite. These are the ones that you have learned. There are more allotropic forms of carbon, but you have learned only two, diamond and graphite. There's yet another point you need to know about alkali metals, that they have low density and low melting point.